Alright, solving by completing the square. Begin this note session by copying down this first part of the definition, some different ways of describing it, as well as your steps for solving quadratic equations by completing the square. Alright, let's take a look at some examples so that you can understand how these steps play a key role in deciding how to solve these problems. So first thing we need to do is identify ax squared and bx, that's x squared and 12x, and get them on the same side as each other. I'll begin by subtracting x squared to both sides, or 12x to both sides, and that gives me the equation ready to go. There is no a term, so I do not need to factor it out. I will be completing the square by adding b over 2 squared to the left side of the equation. 12x plus b over 2, which is 12 over 2 squared, equals negative 20. Once you've added negative 12 over 2 squared to the left side of the equation, your equation is no longer balanced. Remember, equations only work if you add the same amount to both sides, or take away the same amount from both sides. So in step number 3, balancing the equation means you must add the identical amount to the right side of the equation as well. This becomes the perfect square trinomial of x squared minus, that's 12 divided by 2, which is 6. Sorry, and that is x minus 6 squared. This side over here becomes negative 20 plus 36. 6 squared. Please remember that a negative squared always becomes a positive. Do not make that mistake. Once you simplify this, you get 16. X minus 6 squared equals 16. On to step number 5. By square rooting both sides, we remove the exponent. X minus 6 equals plus or minus 4. There are always two solutions. Much like absolute value for this particular problem, rewrite it as x minus 6 equals 4, x minus 6 equals negative 4. Solve both, and you get x equals 10 and x equals positive 2. Number 2. This time, instead of moving the x and the x squared term, we will be moving c. That's going to be x squared plus x equals 1. Now we are going to go ahead and add our value b over 2. That is going to be 1 over 2 squared equals 1. Immediately balance the equation. 1/2 squared. Remember, you balance the equation by adding the identical parts to both sides of the equation. Factor this out into a perfect square trinomial. That is going to be x plus 1/2 squared equals 5 over 4. Square root both sides, and you're going to get x plus 1/2 equals plus or minus the square root of 5 over 2. Then I'm going to subtract 1/2 to both sides. X equals negative 1/2 plus or minus the square root of 5 over 2. You can leave it like this, or you can combine it into a single fraction, which is also correct, plus or minus the square root of 5 divided by 2. All right, question number 3. We're going to rewrite this. 3x squared plus 18x equals 45. This is the first time where you'll have to factor out a. Factor out the 3. When you do that, you use division to factor out the number 3. So you get 3 times x squared plus 6x equals 45. Divide that factored value out to the other side of the equation. X squared plus 6x equals 15. Now I'm able to complete the square by adding b over 2 squared to the left side of the equation. 6 over 2 squared. Remember, immediately balance the equation by adding the exact same amount to the right side of the equation as well. That means I will rewrite this as x plus 3 quantity squared equals 15 plus 9, which is 24. Completing or solving this problem for x, we square root both sides, and we get x plus 3 equals plus or minus the square root of 24. It's at this point that we have to do two things. The first thing is to move the 3, but the second thing is to simplify the radical. Subtract 3 to both sides, and I get x equals negative 3 plus or minus. Let's go ahead and simplify this into 4 and 6. There's my perfect square. The 2 comes out, the 6 stays in, square root of 6. And there's your final answer. The last one, for this particular part of the exercise, what we're going to do here is move the 10 to the other side of the equation by using subtraction, and we get 3x squared minus 6x equals negative 10. Factoring out a is going to be dividing everything by 3. Now I get 3x squared minus 2x equals negative 10. Dividing out the 3 to both sides, I get x squared minus 2x equals negative 10 divided by 3. Going to add b over 2 squared to both sides, plus 2 over 2 squared equals negative 10 over 3 plus negative 2 over 2 squared. Going to complete the square or create my perfect square trinomial. That's going to be x minus 1 quantity squared equals negative 10 over 3 plus 1 is going to be negative 7 over 3. Next thing I'm going to do is give myself some more room because I kind of ran out here. And I'll square root both sides. Now it's going to be x minus 1 equals the square root, plus or minus the square root of negative 7 divided by the square root of 3. I write that intentionally because I will be rationalizing the denominator in this particular process. So it's going to be x equals 1, move the 1 to the other side using addition, plus or minus I square root of 7 divided by the square root of 3. The last thing I've got to do here is rationalize that denominator by multiplying both the top and the bottom by the root 3. X equals 1 plus or minus I square root of 21 divided by 3. Final answer. Okay, standard form to vertex form is what you do, or in order to convert from standard form to vertex form, you must complete the square. So basically what we have been doing these 4 examples is changing from standard form to vertex form. Now you'll notice that in this particular case there is nothing on the other side of the equation but an f of x or g of x or whatever variable is used. So that is why step number 3 is balance the equation and not add the number to the other side. Balancing the equation can also be achieved by subtracting the same amount to the same side of the equation. I'll show you what I mean in the next several examples. So now instead of moving the 12 to the other side, I am simply going to group the ax squared plus bx term, and I will leave 12 out of the grouping. I will be adding, this is going to be equals f of x, so I'll just put an empty equal sign there. I'll be adding b over 2 squared to the left portion of the group. So that's going to be plus 16 over 2 squared minus 12. Balancing the equation means that if I add a number to one part of the equation, I can balance it by subtracting that same number to a different part of the equation. So that is what balancing actually means when I talk about balancing. Okay? So that's going to simplify down to the trinomial x plus 8 quantity squared. Minus 12 and minus 64 is going to give me negative 76. And now I can complete it by leaving my f of x there. Let's look at another example to make sure that we've got it before moving on. Okay, again we're going to group 3x squared minus 18x plus 7. I'm going to factor out my a, so that's going to be 3 times x squared minus 6x plus 7. I'm going to remember that I factored out that 3 minus 6x. Then I'll be adding b over 2 squared to the left side of the equation. To balance this, I will do the exact opposite by subtracting b over 2 squared to the right side of the equation. Now please remember that I have 2 different weight values here. Remember, the original value had a multiplier of 3 on it. Therefore, this number right here must also have that same multiplier on it, or else I will not have a balanced equation. It's like looking at a scale like this, where I try to balance it. Here's my balanced side. By adding a large block, that will be 3 times b over 2 squared, and then subtracting a smaller block and expecting it to be balanced. It will not be balanced when if you don't put that multiplier on there. Okay? So be very careful about your multiplier before finishing your equation. So that becomes 3 x minus 3 squared minus 20. That is your standard form. Okay, be ready to discuss number 7 in class. We will go over it together, but be prepared by having it completed, or at least partially completed, before coming in.